KCC105 for week 5 and 6. We've been talking about linear and exponential growth. Another word for exponential is compounding growth. And we're going to see some other examples because I need 3 examples for you for the assignment. The first example from the first 2 videos, we're talking about interest rates. If I put my money in a savings account, they give me the percentage. I can calculate percentages. I can approximate a linear growth. Here we say, oh, it's about $7.25, and then just use that to approximate, and we can see linear and exponential growth. And this is nice. But I need 3 examples. So let's find another example. And I'm going to set up the table and show you where to get the data. So what do I got to do? I need to set up with a exponential growth. All right, I'm going to abbreviate it here. And I need a linear growth. Now what do we need? I need numbers to start this process, and then I use the formula to get down the line. So where do I get these numbers from? I have some links for you in Blackboard in the course documents. The first one is Bureau of Labor Statistics. Great government website, tons of data about economic information, and obviously in terms of modeling exponential growth and so forth, this information is good. Employment statistics, we can find salaries. So this website, if I go to May 2015, occupational profiles, you have tons of jobs. I mean, just tons of jobs. Go search through those. Find a job that might be of interest to you. For simplicity, I'm clicking chief executives. So the bigwigs. Bigwigs, right here. Lots of more information, but mean annual wage. Here you go. You can find the average salary. Average salary for a chief executive, $185,850. Must be nice, right? And that I can start off there. $185,850. And remember, it's the same between the 2 right there for the starting year. Oh, and by the way, what year am I in? I think that's 2015. Yes, 2015. Okay. Next up, let's go backwards. And now let's go to 2016, because remember, we need to find the change. Occupational profiles. Lots of jobs. I'm going to pick chief executive. Here we go. Annual, hey, they got a pay raise. $194,350. All right. So next year, $194,350. $194,350. You get the idea, and that's 2016. You see where I'm going with this, right? Just like before, I highlight those 2 numbers. Oh, my goodness. Whoops. Highlight those 2 numbers, pull them down. Now, I don't have a formula yet, so I need to do a little bit of work before I can pull these numbers down. Well, it's the first thing I know. I know linear growth equals, well, how much did it change every year? You can take out your calculator and do a little calculations to find out. I'm going to do it on this spreadsheet. Equals this number subtract that number. You see what I did? It's the E30 subtract 29. What's the difference? This is 8,500. In other words, that chief executive, I'm going to approximate, they're going to get 8,500 every year. We know that formula equals that number plus, whoops, there we go, 8,500 every year. Pull it down. There we go. And you can see the linear growth. It's the same every year. The same, the change every year is 8,500. Now, over exponential growth, I don't have a percentage. Back up here, American Express, they gave me the percentage. I don't have a percentage. I have to do a little work. So exponential growth. Now, exponential growth. If I need a percentage is a division. What am I dividing? Divide that change, 8,500. Divide it by that original number. The original number right here. And I get this crazy decimal. That looks a little out of sorts, but if you go up top here, like I said, there's all these menus, but I want a percentage because exponential growth is a percentage. And by the way, if you'd like to see visually a formula, here's the formula for exponential growth. It's change divided by the original money number. So you see the change, we already did the change, it's 8,500 between those numbers, and you divide it by the original. So either way that works out for you, you get a percentage, we know what's up now. Equals, click this box. Exponential means multiply, parentheses, 1 plus that percentage. I'm going to type it in, 4.57%. We've seen that formula a couple times now. Now that I type in the percent, I can pull it down, and I've got some numbers. And you see that here, yeah, there's a little more difference. Highlight things. We can go up to insert. We can make a chart. Ta-da. Nah, I don't like those ones. I like the ones with the lines. And you see the lines are going to look similar, but as long as the graphs are labeled well, that will help me figure things out. And remember, how do I get the x-axis? Add x-axis. What data? Here's my x-axis right there. I say OK, and it gives me the years. It says, hey, by 2022, there's a significant difference in the money. So the graphs should look similar, but the data, obviously, is going to be different. All right, there's 2 examples. Bank rate, salary growth. What are some other ones? We did this past and future population. That was last, I think, for the week 4. So you could say, hey, between 1950 and 1955, you could figure out what the change is. Oh, hey, look, they give you the percent already. And you know what? You don't have to be between 50 and 55. I mean, that's kind of old data. If you go way down here, where is it? There we go. There we go. This is more common between 2010, or more recent, 2010 and 2015. You could say, hey, here's the population, here's the new population, and there's the percentage change. So they give you more information right here from that information about Afghanistan or whatever country you'd like. From this information, you should be able to make another grid like this. What are some other things? Stock data. If you want to go, okay, finance.yahoo.com. I could go to Apple, hit search. There we go. All right, hey, here's some data on Apple. Oh, wait a minute. This is just today's data. No, I don't want just today. Let's go for 1 year, and it says, hey, this time the price is $159.85. If you go all the way to last year, look at it, says the price is, there we go, 132. You see that little black square on the side, 132. So you have two numbers. You can calculate percentages. You can calculate change about that. Here's another example. I found a city of Chicago. They got budget information for 2017, 2018. I searched. Here's 2017. There's your budget. Local funds. Obviously, there's different ways that money comes into the city, but local funds, $8.22 billion. 2018, $8.58 billion. I can find out the change. I can find out a percentage. So I was just clicking around. And guess what? If that's for city of Chicago. If you just go to random internet searches on a topic of interest to you, hospitality. Hey, Hawaii visited. So I just read this article. Hey, here's visitors. 4.6% increase. Wow, I'm ready. I can use these numbers. I can use these numbers to calculate a grid like this. So don't let yourself limit yourself to just economic data. We could say, hey, hospitality data. Look at, here's the price of a hotel, how it's changing. So find something of interest to you. Go dig in and then create some of these graphs. Remember, everybody's graphs should look the same. It's all about the subject matter and the data you put in that's going to differentiate things. So once you have these, you're going to put these graphs together in a graphic, and you'll see my example, and that's what I'm looking for. Week 5 and 6, due Sunday, February 18th. That's about a week and a half. Any questions, reach out for me, and we can make some solid graphics for this assignment.